This is nearby, Scheveningen. This is one of the few off-grid systems we have. It's on a beach cabin, you might say. We take them off in the winter, we put them on the beach in the summer. Policy goals. The Netherlands, we have RES's renewable energy sources. We have a goal in 2020 of 60% of the total energy demand should be renewable. That's a contract more or less would be okay, how we are going to fill that in, that depends on the efficiencies and all the policy considerations. PV is a small part. It's a small country and it's densely populated, so we don't have a lot of room for PV. Megawatt parks, they don't exist in the Netherlands. At this moment, it's only just 0.08% of electricity production. So, that's the latest figure. We don't know exactly because we don't have an obligation in the Netherlands to register your solar modules. Like in Germany, that's more or less an obligation. So they know exactly how much is there. In the Netherlands, it's a bit of guesswork at this moment. The top sector goal is 3% of total electricity production in 2020. So if by heart that would be a multiplier of like 100. Okay, thanks. That's installed capacity. If you have any questions, just a quick one, you can fire them immediately. And I will
yes, thank you.
Stop and have some time to answer that. So, installed capacity in the Netherlands, you can see a clear early 2000. We already had some pioneering applications. Then more or less a steady, nothing happened between 2004 and 2008. And then we got something like a feed-in tariff. Then you see a small increase, not very much. And then in 2010, the last 3 years, you see an incremental increase of almost 100% each year, and that's because of the dropping module prices worldwide. So, what are the market segments in the Netherlands? Most is just like here in urban regions, rooftop-based smaller systems. There's almost no grid, off-grid. I mean, that's usually only traffic systems, emergency systems like that. So no off-grid in the Netherlands. Then some technical details about the feed-in tariffs that was stopped in 2011. And now it still exists, but only for larger systems, above 50 kilowatt peak. And that has a maximum, so it's capped. It's not a feed-in tariff without the limit. So, okay. Maybe it's good to mention that the feed-in tariff system in the Netherlands was never intended to boost our internal market, because most of our production is for the export anyway. But it was intended for preparing the market, all the players in the market to know each other, to get some quality control, to make some meters, you might say, and then be ready for this large export market. Right. The trend, well, we are seeing some larger systems at this moment, but the small system market is taking off. We have a few trends, and that's mainly that there are initiatives organizing themselves. That's joint purchasing, solar modules, for example, in China. That can be any company or even cities do that. Some colleagues do that. So that's like a hobby at this moment. There are hundreds, maybe thousands of collective actions like that. And we have more formal energy corporations. There are people who are aggregating their own energy demand together in local energy companies. There are other constructions like leasing, but that's for the next. So I don't see any reactions. Next, please. An example of a somewhat larger system. It's a beach resort in the south in Zeeland. Very nice. Next. This is an old. This is about production. So where the yellow arrow is, that's where we are with the 200 others. So we're not in the major league when you're talking about cell and module production. That's in 2009. China will be now more than doubled. But what happened is that we did have some module producers, especially Schouten and Solland, and they were generating employment and revenues were all right. And the moment, so you see the increase in our market. At the same moment, you see that the Dutch module producers being taken over, and production all over Europe is being hit very hard by this dropping prices. There we also have manufacturers of machines. Those machines are being sold to Asia and to other countries. They had a steady market going, but now because of the overcapacity in worldwide, also in China, also their demand is dropping. The difference between them and the module producers, they can switch their activity to another sector. So they are more or less doing still fine. But not in solar at this moment. That's, yeah, okay, let's continue. So a few of the products that were more or less invented or developed over here, because we have an innovative market. It's not a big market, but if you are interested in innovation, I think the Netherlands would be the perfect place. That's thin film, so not the multi-crystalline baked plates. Thin film, in that case, just glued upon metal constructions, lightweight, less efficiency, but still interesting. That's also the reason why we can use them on historical buildings, because you don't have to adapt the heavy construction.
Can that be done on glass?
Yes, I think, I don't know anybody who tried that, but that should be possible, I guess. But with glass, I think you're binding yourself in the tail, yeah. But we have, because you also have solar glass, that's more expensive, but yes, I think you could do it on that also. But then you lose your light, so I'm not sure where you want to use a specific example. Yeah. Okay. So historical buildings, next please. That's glass, that's a startup from the Eindhoven University. They received some funding from us, just small startups, companies like it, and they can change the color of the glass. So you have with a little button, it's almost completely transparent, and you can turn it down so it goes dark almost.
Is it something that you can use in greenhouses, for example?
Yes, that could be, but I think the economics for greenhouses are not that suitable because this is rather expensive. This is more for headquarters, banking, or maybe a bit more show-off. So, in the greenhouses, you have to think about economics. Yeah, maybe plastics are much more combinations with cheaper materials. But then, yes.
So this is what I was just asking. So is it possible to have that on glass that is cheaper than having this made of plastic itself?
Yes, there are. Yes, there are even products in between that you cannot regulate, but they are more or less transparent.
Yeah.
So the efficiencies are not that high, but you can look through and it will be brown or this one I guess it's you'll be up market. Next. This one is much cheaper, made by a company, D-Mark, that's not from the solar sector, so that's what we like to see. A lot of innovation comes from outside the sector. This innovation was mostly in the production. He managed to produce a combination of solar and thermal heating in a very cost-effective way. So this will be suitable for rooftops all over the world, I guess, and it can be used also for heating and cooling. That's not just your house or your building, but also the solar panels in themselves. So it improves the efficiency of the solar panels.
How does this cooling work?
It's a water-based system.
It's
So
air conditioning.
Yeah, it flows back. It flows, the same water flows on the back side of the solar panels, in little tubes.
You heat it up.
Then it gets cool. Okay, well, if you're interested, D-Mark can tell you all the specifics. Next. We're going through research. I'll speed up a bit. This is Professor Selman, one of the at the University of Delft in thin film research. He has more than 20 years or 30 years track record. What we more or less spend each year has increased a little bit, but it's more or less the same. It's between public money for development cost like 20 million, 50 million. Added to that, you have research funds for fundamental research. But that's not in there. Focus of the research at this moment in the Netherlands is on cost reduction in general. So that's in manufacturing equipment, but also in the design of solar modules. Thin film, built integrated, but PIPV, built integrated PV, and also grid integration increasingly. Solar fuels, I just would like to mention them. That's one of the newer areas. It's not that market ready yet, but we do have some large projects on that.
What is solar fuels?
Solar fuels. What is solar fuels? That's really capturing carbon directly from material or from air, and you use the photovoltaic effect of splitting those molecules. So you can, I'll have a few examples, just one example of that. You can produce fuels directly, but it could also be gas, like methane. Yeah. Little statistic, bit dated, about the Netherlands in yellow, our position worldwide when it comes to patents in solar. So, not with the major league, but not important also. Next. This is one example of how you can use solar. Stimulating, you might say, or firing enzymes for producing gas methane in this case. But this is a chemical route where you can take different directions. One is to gasoline, biodiesels, and other raw materials. But one of the benefits for solar is that you can solve some of the storage problems you have when you have overcapacity or you cannot sell your energy into the grid. So at this moment, it's mostly larger off-grid systems who are looking into this kind of application. So that was a very quick overview of the Netherlands. Now I would like to just try if I can sketch something of what I think it's happening, but correct me if I'm wrong, in the sub-Saharan countries. I have three categories. Where the first one is very large systems, so that's tens of megawatts up to a gigawatt. That's where they want to go. They're not. Don't think that they're there yet. What's the benefit? That's the efficiency of scale. The operation costs go down in a megawatt park. One of the first business cases for the utilities was peak shaving, especially in the tropics where you have a lot of air conditioning during the daytime. PV is very well suited for topping that off. Again, we target governments and utilities. That's your market. Large investment projects, tens of hundreds of millions. Important here is the total cost of ownership. There were not very many large parks like this, so to have a real understanding of what they are, that was one of the things we studied in the International Energy Agency. That's up there. PVPS, power, photovoltaic power systems, task 8. There are some problems. Grid integration, of course, if you know, but there are also some solutions. One simulated and designed by Christian Breyer from Germany is the combination of solar, wind, and gas-fired backup, for example. So you get a much more equal profile. Very manageable. Another one, local usage of energy, like in desalination plants, industrial parks, major cities. And the other we already mentioned, converting electricity to gas, power to gas. So, next market. We go a bit down, yeah, into the megawatt still, maybe a little less. Medium-sized, usually microgrids or integrated into a city or a neighborhood. There was a special task also in the International Energy. That information is available for everybody about previous experiences in projects like this. The task 11, led by Canada. Their first business case was replacing diesel in remote areas, islands, but also in some cases, especially cattle driving, you have less maintenance for your water pumps. You don't have to visit them every day. Problems, skills are required for maintaining and the grid and the whole system. So that depends very much on where you are, the educational level. What is your contract? Is the community doing it themselves, or do we have a maintenance contract with an external party? Local ownership and care required. That's one of the most important things from their experience. And your market is usually local communities, local governments. Business parks, sure, could still be. Public finance, that's one of our problems because we have this innovative market and we would like to develop new products that are more suited for your local circumstances. But this kind of governmental funding is usually for proven technology, or you might say older systems. So there are some business opportunities if you go just a little bit beyond that. Public services, that's of course one of the reasons you can do this. Health, refrigerators, cooling of medicine, etc. Important services, education, lighting, public lighting, we're talking about here, I think. Public buildings, of course. Water pumping, treatment of wastewaters, agriculture. Agriculture is here, we come to the greenhouse again. That's a very wide area. That's especially one where you can imagine doing some more research just to find out how to tune that, what's interesting, what's not. And the last market is more what we call the eco-services, small, sometimes portable systems. there is a special task looking at this one and the previous one, task 9. It's usually about telecommunications, television, internet, lighting again, but then on a personal base, replacing oil lamps or other diesel application. Here you target individuals, families. You're really looking at the marketplace. I don't think there are feed-in tariffs. Maybe there are, but I don't think that's needed even in this kind of market. Problems, yeah. Sometimes people in those situations, they are afraid, also with the microgrids, that will mean that they will not get a connection to the grid. So governments will say, you already have your local energy, there's no need to connect you to the national grid. So that's the reason why they're maybe a bit hesitant to adopt microsystems. Again, maintenance, keeping it functioning, quality control, recycling of materials is a big issue, of course. How do you collect all those little applications? There are metals in it, there are acids from batteries, etc. So that's an important. And you can see this is ideally equipped for industrial partnerships, because those applications, they serve something. It's for your mobile, it's for your refrigerator, or your television. So here you can look to industrial partnerships for developing those and distributing those products. Okay, I think I'm almost done. Observations from my side. I just have a few in reserve in case there's no discussion. I see energy is a bottleneck, just from an outside. Energy is a bottleneck for the sustainable development of for example, Nigeria. So we're not talking even about renewables, even if you just look at the energy supply, you're going to need more energy sources than you already have. With integration problems are underestimated in all the 3 markets, I think. For utilities, I don't know if there are people from utilities present, but I think it would be a good idea if they jump a few technologies. So they don't go with the proven technology, but they look into IP, Internet Protocol, smart meters, etc. And that's something you can do when you're starting from I don't know where you start from really. So, but that's important. Still, no coherent approach with the corresponding financing now. Here, maybe as a government agency, we could do some work on the road mapping. And then I don't mean what usually happens, you get the road map of somebody else. No. You would really ideally have your own specific tailor-made road map for the specific problems and situation in your country. Research required, yes, into system integration. That means not only in the built environment, but also with the grid. And local circumstances. For example, dust. We have a lot of rain. Dust is not a problem over here. I guess it will be in some parts of Nigeria. Theft. Not really a problem at this moment, but we have a problem with vandalism. Those are very specific things that are usually, they don't pop up until you have some experience in the market. Shared research projects, I think there are financing possibilities for that. And then the last one, really what you're doing right now, explore possibilities of local production of applications. So you don't go, you import maybe the cheap Chinese modules, but you integrate them in your own applications. That would be an interesting area to go. Okay, thank you very much. My email is on that